must be equal to the weight or volume, whichever you like to say, of the roller. Therefore, each roller in itself is a generator of its own. Here is a magnetic demonstration with so many people witness. There are letters in the books of people from Australia who saw this demonstration. This particular one is from the report of Gunnar Sandberg of Sussex University. Unfortunately, he gives you a slight wrong explanation. He says when you place the roller at the edge, it accelerates to its cruising speed. He could not tell you at instant go to the cruising speeds. The other people tell you in their report it goes instant to the cruising speed. Why should Gunnar Sandberg say it accelerates? The reason is this. He works in the electrical department of Sussex University. He should know why it goes instant, and he does not know. It baffles him. If I was in his place, I would say, this goes instant to cruising speed, but at this time I cannot explain why. But we will investigate it and tell you when we know. It would be much, shall we say, polite, much more professional than the way he went about it. You see, as we shall explain a little later why it goes instant to its cruising speed. Now this is the reason why the roller rotates. We have 4 elements. You see the colour showing each element. What is happening, we have energized with DC, and on this DC we have used AC. The AC and the DC must be switched on exactly at the same instant. The AC must be at 0 point, and it must be on the upward climb. It must switch off at 0 point on the complete of a cycle. If you fail to get that right, the AC will erase the DC. But if you get that timing dead right, you're left with thousands of little pinpricks of forces. It is difficult at this time to say if these are true magnetic points, or whether we have got surges of electrons on one side and surges of holes on the other side. But one thing is certain, that if the plate and the roller are magnetized precisely the same, we have a strange position. And it says, you have got one pole there, but you don't have a pole there. The pole is over here. The next pole is above, that is not in line. You have a wave. What happens is that when you place the roller on that plate and you let go, the magnetic field lifts the roller. But at the moment this happens, eddy currents form. It pulls the roller down. If your sums are right, they balance to a point where the roller floats. It does not touch the surface. There is such a torque that the roller must rotate, and it rotates on its axis. Now, if we only have 2 lines of magnetic force on each end and 2 on the plate, it sits there, smiling at you. And that's no good to us. So what do we do about it? The answer is simple. Do something. I take the bar, I cut it in 8 segments. Now, I do the energizing again on each segment. Now we have something completely different. We have still got the 2 outer ones, and they fit on the plate with the 2 on the plate, and the roller cannot move either way, sideways. But now, you see, we have gotten 6 more runs of these mysterious poles. They are exerting a force on the plate, so it accelerates. Another beautiful thing about this is you just drop it on the plate and away it goes. And they say, how did you do that? I didn't do it, that did it. I look at this and I say, why do we always take the hard road? Because when you drop the next one in, it just sorts itself out. It finds its opposite point to the one operating. Every roller must go the same way. No matter how many plates you have, they will always go the same way. Now the question is, how do we find how many rolls you want on the first plate? Because we obviously need to know that we got a steady output. Well, the sum is quite easy. You take square 3, you know the answer. You're all going to say 9. You're wrong. It's 9 fields. Every field has a value. When you calculate these values out, it is the sum of each column or each row or the diagonal. It's the answer to the material quantity you need. Every element is defined by that square that you're going to use. It is the right assembly of this material that makes this technology possible. When you do the magnetizing of each segment, if you got your sums right and you powder it with fine dust, you're looking at a magnetic field you have never seen. It is a bicycle wheel. It is exactly the spikes of a wheel. When you turn it up on its running edge, you just have this wave pattern. Holding it separate, that's nothing. There is no reaction, nothing. As soon as you put it on the plate, you have instant reaction. But it is instant. Whatever the cruising speed is, it travels instantly, it's free to go. There is no acceleration. We'll now take the next view. As you see, what we have is actually 2 waveforms going one direction, and then we actually got 2 others going in the opposite direction. We'll look at next. Now this is an enlargement of one of the plates, and this actually is a true plate. We give the measurements, we show you the ingredients we use. As you see, we use a rare earth at our outer edge. Then you see we use a nylon, and I like to say why I fancy nylon. We can use plastic, but in Germany we see, when I look at the finished thing, that the nylon, the plastic looks terrible crude. It looks hard, it looks brittle, and we believe that nylon gives a better finish. It's an insulator. It has a double gate. But there are 3 classes of nylon 66. That's what we call a positive charge. This is where the manufacturer takes away electron from each molecule. You can have a neutral, which is the standard one. Then you can have a negative charge. This is where they add an extra electron to each molecule. And it's the negative one I use. Next to that, we take an ingredient. It can be iron or any other of the magnetizing materials. And then on the outer coat, we put one which will not magnetize. But it must produce an eddy current when a magnetic field comes in touch with it. That is the basic of it.